Right, just finishing off the review then for lesson 22. We're looking at logarithms and exponentials. So in the previous course you were introduced to logarithms, and what you found was there was a relationship between exponentials and logarithms. So that's saying that for y equals b to the exponent x, in order to solve for that exponent, we can't use our regular algebra rules. So there's an algorithm out there, or an inverse function for everything. So similar, off to the aside here, if you square a function, the inverse, let me change that a little bit there, the inverse is square root. All right, if you take the sine of a value of x, the inverse is sine inverse. So very, very similar. The y equals b to the x is an exponential. The inverse of that would be x equals log, and the base then is a b, and it is of the y value. So now you're finding the exact value for x. All right. So some of the rules with logarithms that you're going to find handy. First one would be that log any base, so base b of 1 is always equal to 0. So that's one of the general properties that you would have learned last semester. So anytime you take a logarithm of 1, it'll always have a value of 0. And that's because it crosses the x-axis at 0, 1. Or sorry, 1, 0. It's an x-intercept. If you have log base b of b to the exponent x, what essentially happens here is you have an exponential. And so what you're really doing here is that you have an exponential function, and inside that exponential, or in the exponential function, you're taking the log. So those are functions. They essentially, they undo each other, which means that once you undo each other, you're just left with x. All right. Similarly, if you have it the other way, such that b is to the exponent log base b of x, same thing happens here. You have a logarithm and you have an exponential going at the same time. Essentially what happens, they're inverse functions, they undo each other, which results in a value of x. All right, so there is your 3 general properties, and then just for purposes of easier for me to write here, we're going off to the side. Rule 4 that we look at, or the 4th property, or however, it doesn't really matter what you call them here. If you have log base b of 2 arguments, say m times n, you can expand that or rewrite that as log base b m plus log base b n. You can also have some division here. So m divided by n. So log base b m divided by n. This then would expand, and you would end up with subtraction. So the division then results in subtraction of terms. And the 6th and final one here that we're going to look at is log base b m to the exponent n. What happens then when you go to simplify that, that exponent moves out front, it becomes a coefficient. So the rule ends up n log base b of m. It would be the equivalent expression. So there you go, there are some of the rules. I'm talking about some of the usage and how are we going to use it when it comes down to this course. So we don't have to worry about calculating values or solving equations. We're more worried about the manipulation and solving logarithmic expressions. So for example, we're going to end up with something that looks like this. Log x plus 2 plus log x minus 5 minus log x squared. So if we end up with an expression like this, sometimes it's easier if it was simplified and more compact. So using the properties from above, anytime you have addition, so right here, we know that the 2 arguments are going to be multiplied together. So the result will be the log And I'm going to cheat here. I know what it's going to look like. I'm going to have x plus 2 on top, x minus 5 on top. And because the last term is being subtracted, when we use or apply our properties, it will then appear in the denominator. Brackets weren't really necessary there. So we can take a complicated expression like this one here, and we can then reduce it or simplify it to one expression. Okay. Second one here, what happens if I had 4 log, let's go x minus 1 minus 3 log 2x plus 5 plus 1/2 log x. So now I'm doing sort of the upper end. Where did these coefficients, or what do we do with the coefficients that are appearing here? If we look above at rule 6, that coefficient comes from, how do I get rid of that? Oh, there it is. Coefficient becomes the exponent. So when I go to simplify this or write this as one term, we will have log. That x minus 1 will now have an exponent of 4 on it. The second one is minus, so it means there's division, so it's going to go into the denominator, 2x plus 5, and that would be cubed. And finally, the last one's adding, so it appears on top, and it will be x to the exponent 1/2. All right. Now number 5, or actually, sorry, not number 5, final example. We also want to be able to go the other way. Nice to see that was fixed in the upgrade. So example. And this is actually what we're going to do the majority of the time. We're going to be using the simplify option a little bit, but actually expanding is going to be more important for us, because what's going to happen eventually is we're going to be dealing with a question that kind of looks like this. X minus 5 cubed, x plus 2 squared over 2x minus 4 to the 5th. That's going to be in brackets. What we're going to be asked to do is take the derivative of this function, and when you have a complicated function like this, it's easier to deal with one element at a time. We can deal with one element at a time by using the properties to expand it out. So the x minus 5 cubed would be written as 3 log x minus 5 plus the 2 then on the second term would become a coefficient log of x plus 2. Of division, so that bottom term will be subtracting 5 log 2x minus 4. There we go. So there's your expansion taken care of. All right. One more example with that, I guess. So log of, let's go the 4th root of, let's go 2x plus 3 squared over x cubed. So we'll do this one in stages. So this is really the log. I'm going to one bracket system here of 2x plus 3 squared divided by x cubed. Now that's to the 1/4. And now you can go a couple of ways with this, and the one way you can look at it will be 1/4, and if you're going to look at it a different way, you can easily expand it out your way, and you should get the exact same answer. X cubed, so that 1/4 goes out in front. Now what happens when you do the expansion, but when you do the expansion, the whole thing will be multiplied by 1/4. So you end up with 2 log 2x plus 3 minus 3 log x. And you divide or distribute that 1/4 inside the brackets there. So there's a couple of examples. This is the upper end. This is where you would have left with algebraic manipulation in the grade 12 course. So it's very, very important that you can complete or you understand these examples. If you're having trouble with this or you can't remember this, I can easily give you some worksheets to get you practiced up on this. But if you can do these skills for me with logarithms, then you'll be perfectly fine. The last topic here is trigonometry, and after doing the vectors component first in this course, I really have nothing else to add to this. We need to know our SOHCAHTOA. So if you're comfortable with the trig, this is pretty much when you shut the video off. SOHCAHTOA, Pythagorean theorem, it's kind of nice because we do go back, we're going back to basics here. So really, you just need grade 10 trig for this part, or the base skills for that anyway. We will use sine law, and we will use cosine law. And since we're not solving equations, we don't need the cast rule, so that's not one of the areas that we're concerned with in this particular course. So there you go. So there's the end of the review for Unit 3. And like I said, if you have questions with any of the components in there, it's very, very important to let me know, and then I can, A, go over the topic with you, and B, provide you with some supplementary material just to make sure the skills are there. But if you can do or follow along with everything I talked about in the review, then you know that you have the base skills that are necessary to be successful in this unit. Good luck in this unit, and all the best.